Okay, now it's a live streaming video of IR sensor, how it will work. Now see here, this is the IR receiver, this is the IR transmitter. हाथ में लीजिए, take this in hand. Okay, so how you can understand it? This is a positive. Huh? This is a positive, this is a negative. Positive length is a leg length is a more. Understood? As well as this is a receiver. Same length ज़्यादा रहता है. See here now. We want to take the signal of IR sensor, or we want to make the circuit of the IR module. So I will explain the circuit diagram. So here is the transmitter section. So here is normally in our circuit we are giving the 5 volt, but you can give the 9 volt, 12 volt, 5 volt. Okay, it's a simple LED circuit for current limiting. Here is a resistor. We want a more brighter, that's why we have to flow the more current in this IR transmitter. That's why instead of 1K we will put a 100 ohm. Understood? We have to make a more brighter. You see the circuit diagram in your BRD file, and then you can understand where is the transmitter resistor. So we have to make a more brighter. It is always in forward bias. LED lagna chahiye. We have to keep LED on. That's why it is always in a forward bias. It's only transmitter section. That's it only. Okay. For receiving, here is one resistor and photodiode. Photodiode in a reverse bias. Photodiode is in reverse bias. Why it is in reverse bias? I will explain. 5 volt is given here. Ground is here. So we will get the voltage across photodiode at here. So I will make a table here. See here, it's a ray status. Ray status. One is a inserted, another is a not inserted. Means this is a transmitted, this is a receiver. Okay. If ray inserted, this status, someone is come between this, or any obstacle come between this, then automatically ray will not be inserted on it. Okay, it will be stopped. Ray will not be inserted on this ray. Understood? So these are the two conditions: ray inserted, ray not inserted. Okay, so we will write here the photodiode voltage. Whenever ray inserted, see here, first is the ray inserted, then these ray are strike on it. That's why this photodiode goes in a breakdown state. Breakdown में जाता है, it will go into the breakdown. That's why this ground comes at here. So voltage is normally 0 to 0.5 or 0 to 1. Is depend on your where you are doing the project, or where your circuit is placed, or where your photodiode is placed. It is in inside room or it is in outside room, because sun rays also effect on this. Sun rays also effect on this. Now not inserted. Whenever ray are not inserted, then voltage is 4 to 5 or 4.8, like this. It's a practically. Okay. So only that much circuit you can connect to the microcontroller. Suppose you want to interface to the Arduino microcontroller. In this case, we are interfacing to the Arduino. Suppose we have to interface any microcontroller or Arduino, we can't interface directly, because there is a not exact 0 and not exact 1. 1 means 5 volt. It's a 0 to 0.5 or 0 to 1. Okay, means ray not inserted 1. Ray inserted then 1. Not inserted means 4. It's not an exact 0 and 1 status. So microcontroller will be get confused. Understood? That's why we have to make a filter. We have to create a filter at here. So that's why the same signal we are given to the comparator. हमें comparator को देते हैं. We will provide it to the comparator. And here is one pot. This pot voltage is plus 5 volt and ground. pot for variable voltage. We will decide one threshold level or the middle level or filter level between this. Now suppose I have written here the pot voltage. Pot voltage. Now this pot voltage, suppose we will take the condition as a, we will getting 1 if inserted voltage. If where you have to check it at here. आपको यहाँ पे चेक करना है. You have to check at here 1 and not inserted means 4. कितना आता है देखना है. It may be 0.5, it may be 0.6, it may be 4.1, 4.2, whatever it may be. तो पॉट को रखते समय दोनों के बीच में रखना है. मीन्स 2.5, 2.1 और 3 दोनों के बीच में आपको इसको रखना है पॉट वोल्टेज. नाउ सपोज इन सर्किट आपको रे नॉट इंसर्टेड. इफ रे नॉट इंसर्टेड then you want a 1 at here. Okay, means ray not inserted at that time the inverting pin of the comparator should be low. Insert होने के बाद 1 चाहिए आपको. Okay, you can make it vice versa, opposite, only change the pin, plus to minus, minus to plus. So for example I have taken as a plus and minus. So I written here the photodiode voltage and pot voltage. Okay, now photodiode voltage is for example inserted. Ray strike हो रहा है तब ray inserted, then photodiode voltage is a 1 and pot voltage we fix it at a 2.5. So in that condition photodiode voltage is a inverting terminal and pot voltage is a non-inverting voltage. So which is the greater? This is the greater. Means non-inverting voltage of the comparator is greater than inverting. That's why output of the comparator is positive, plus Vsat, positive voltage. Understood? Same at here. In this condition not inserted. That's why here is a, for example I taken as a 4 and here is a 2.5 is a fix. It will not be changed for both condition. Ray inserted not inserted, then only that voltage will be changed. This voltage become fixed. At this condition it's the opposite. Means inverting voltage of the comparator. It's a comparator status. So inverting terminal is more than this. That's why output voltage is minus. So suppose here we are using a 358 IC. So it will give the directly 0 and 5 volt. Then we can connect it directly to the microcontroller. Means suppose here is a 1 volt, then automatically it will convert into the 5 volt. And suppose it is in 4 volt, then automatically convert into the 0. If suppose you want it opposite, means 1 then 0, 4 then 5, then only change these pins. आ रहा है समझ में? Okay. Suppose our circuit developer develop the opposite circuit, then you have to make a change in the program only. Don't go and change the hardware. Ray inserted, then what is coming 0. Then you put the same into the code status. Understood what I am telling? Don't go and change the hardware. Hardware को change मत करो. Suppose in some circuit we are using a 339 or 393 8-pin IC. Both we are using. Suppose we want 2 comparator, then 393 and 4 comparator, then 339 IC. हम use करते. At that time, it gives the 0 and 0.8. Means plus means 0.8 and minus means 0. ऐसा देता है वैसे. So we have to again connect at here a switch, transistor switch. And here is a amplify करके यहाँ पे देना पड़ता है ऐसा. And this connection to the microcontroller. And here यहाँ पे ट्रांजिस्टर ही देखो लगाया है plus 5 volt. Then what happen? If 0 volt is at here, means this one, then automatically this transistor become off. That's why 5 volt is come at here. Okay, and 0.8, that's why transistor become on. On means this 0 is coming at here. Means ray not inserted then 0. Sorry, the ray inserted means 0, not inserted means 5 volt. You will get directly. It's output of transistor collector. Transistor collector. आ रहा है समझ में? It's a output of the comparator. It's a comparator output. It's a transistor collector output. Because we know that transistor is a inverting amplifier. उल्टा आता है ना? Okay, understood. So this is a chart of this whole circuit. इतना ही circuit है. Suppose in this one IC, two comparator are there. Then two IR we can connect to the one IC. In our this circuit we require another IR. That's why we are using another IC. Understood? Okay, thank you.